Afternoon, one and all. We are welcoming you all on the fourth day of the FDP on data analytics and an application. Good afternoon to Rakhi Gupta ma'am, Dr. Rocky Gupta ma'am from the department, head of the department, IT department.
Good afternoon, everybody. Thank you. Good afternoon.
Now I request Neha Patel ma'am from the department of IT to please give a formal introduction of an sir. Neha, please.
Sure, ma'am. A very good afternoon to one and all present here. I, Ms. Neha Patel from the Department of IT at KC College, would like to welcome you all on the fourth day of the Faculty Development Program. Today's session is on data analytics using SPSS. The resource person for today is Dr. Dhaval Maheta. Dr. Dhaval Maheta is a doctorate in management and is currently working as an assistant professor at the Department of Business and Industrial Management at Veer Narmad South Gujarat University, Surat. He has 20 years of postgraduate teaching and industrial experience with multinational finance companies such as ICICI Bank and HDFC Limited. He has presented and published nearly 40 research papers in national and international conferences. He has also been the key resource person for the research methodology workshops organized at NITs and IIMs. He has completed minor research project titled Effect of Money Supply on Stock Exchange. He has also published a number of books titled Statistical Analysis using R Software, Machine Learning using R Rattle, to name a few. Sir, we are very grateful to have you here for the session. I now would like to request Sir to kindly begin today's session on data analytics using SPSS. Over to you, sir.
Thank you.
Thanks, Neha, for a warm introduction. Warm welcome to Sir you. Over to you, sir.
Now, anybody who has installed the SPSS software in your system, just write down yes, at least some of you must have installed it. Please write in the chat box those who have installed it so that I can understand. Please write down in the chat box who has installed it, SPSS. Prakati ma'am, message was given to that?
Yes, sir. Morning only when you forwarded the link and the file also shared into the FDP group.
So nobody has installed it? Okay, fine. Let me share the screen with you. Downloaded. Somebody has downloaded. Who is it? Yes, yeah. 2 people have downloaded it out of 80. Fine. So we are going to work on SPSS only, and one data file also has been sent to you, right? And that is related to employee data. Okay. So I'll start with a blank screen. Not working properly due to low configuration. Okay, that we will see later on. Fine. So we'll start with the first basic thing, that is data. And these days, this word is like a buzzword that everybody wants to be a data scientist. Now, in this data, how many types of the data? Let's understand first that a data can be structured, unstructured, and semi-structured. Again, a data can be quantitative or qualitative. Just let me write in another format. I'll write the data in the center. Data can be The one dimension to the data is structured, unstructured, and semi-structured. The another dimension to the data is qualitative data and quantitative data. Other dimension to the data is cross-section, time series, and panel. Again, another dimension is that I can, from data, my objective of the analysis can be descriptive analytics, predictive analysis, and prescriptive analytics. The types of data can be nominal, ordinal, interval, the data can have 4 qualities. It can have velocity, veracity, volume, veracity, and variety. Okay. Now, depending upon this type of data, from descriptive to qualitative, your softwares go on changing. So today, what I'm going to speak is about cross-section data. It is about cross-section data, quantitative data, covering all of this nominal, ordinal, and structured data. And it will be more a descriptive analysis. It will more be a descriptive. Now, depending upon your requirement, the softwares can go on changing. Here, you require SPSS. Here, you require eViews. Here, you require eViews. Here, you can work on SPSS and R. Here, you require NVivo. Here, again, SPSS can work. Here, you require 9 or RapidMind. So what is your objective function? And on that basis, the things will change. Am I audible, ma'am? Pragati, ma'am?
Yes, yes, sir. The screen is also clear and you are very much audible.
Okay. Now this data, I can bifurcate into 4 levels of measurement. Nominal, ordinal, interval, and ratio. If I talk about human body, then weight is in ratio scale. The temperature of a person is interval. Ordinal is what rank he or she is holding in the organization, and nominal is gender. Okay. So if I say male, female, first rank, the temperature. Now, what's the difference between this and this is that here 0 is not a true 0. 0 is not a true 0. It means that suppose if somebody says that today the temperature is 0 degrees Celsius or time is 00.00, you don't say that there is no time, there is no temperature. Here, 0 does not mean absence of phenomena. But if here I say 0 weight, 0 kg means there is no weight, right? Now, what techniques we can use for data analysis, a univariate analysis technique, which we can use when we are having a data in this format. For example, the first one, the gender. So here at the most, which I can do is I can go for plotting the bar chart. Male, female, right? So all of you open the file which I have sent to you, that is employee data, and we will directly start working on it, hands-on training. So we are going to work on cross-sectional data, in which first analysis which we are going to do is univariate analysis. Now, those who are seeing the SPSS for the first time, it is having two windows. One is data view and another is a variable view. In data view, variables are like this, and the same variables, you can say the characteristics of the variables are defined here. First of all, let me remove this because this is of no importance right now, and I will remove this. I clear it. Clear this up. Okay. Now just see gender. It is here male and female. Now I want to report that how many male or how many female are there in my analysis. So analyze descriptive statistics, and I go in frequency. All those who are doing with me, please write down done. When I click on this, you will get this. Please write down in the chat box done. If you are here, those who are working with me, please write down done in the chat box. Okay, fine. Now transfer gender here and click on statistics. Normally, in case of categorical data like male and female, we don't compute mean because it is useless to say that the mean gender of the survey was 0.6 or 0.7. You cannot write that such words cannot be used, and therefore mean is never calculated. Let it be. Go in charts. Make sure that you activate bar chart or pie chart with percentage on, continue, okay. And see, it gives me the result that out of 474 respondents, 45.6% are female and 54.4% are male. First analysis complete. This is univariate, one variable, nominal data. If you double click on it, it gives me an option that I can display my percentage here. When I click on it, it will give me the percentage. Depending upon my requirement, I can change the button. I can keep my percentage wherever I want. Normally, I keep these sessions as hands-on training. All data analysis, machine learning, my workshops are hands-on training, like Tableau, Power BI, right? Anyway, it's fine. Let's proceed further, and you can get the percentage. Again, come back to the theory. Now, if my data is ranked, like assistant professor, associate professor, and professor, what type of data analysis I can use? Again, I will use here the same technique, and that is the bar chart. Here in our data file, we are having clerical, custodial, and managerial. And therefore, I want to have a bar chart of this. So where I'll go? Again, I'll go here, analyze descriptive statistics and frequency. Transfer here, employment category, charts, bar chart, continue, okay. And it gives me the result of clerical, custodial, and managerial. Is it visible? Say yes or no. Chat box. Is it visible? Hello.
Yes, sir. Yes, it's visible.
Yes, yes, you're visible.
Yeah, fine. Now comes this data, this type of data, where data is continuous. Wait, we are having a continuous. It means that, say, for example, if we are having two students, 34 kg and 35 kg, is it possible that there can be a student between 34 and 35? Yes, it can. And therefore, it is continuous. But let us talk about this data. There is a male and there is a female, right? Can I have any other, you can say 1 and 0. Can I have any other gender here? No, that's not possible. And therefore, it's very clear-cut demarcation: male, female, clerical, custodial, and managerial. But here, the demarcation is not continuous. And therefore, if you remember in our school days, we used to have some sums like this, that in 0 to 10, how many students are there? 11 to 20, how many are there? So here, we make a histogram, right? We make a histogram like this with frequency polygon. How we can do this thing, and on what type of variable we can do this? See, gender is categorical, education is categorical, job category is categorical. How I am saying this thing? Let's see and go there. Job category, if I open this values, you see clerical, custodial, and managerial, right? Only 3 categories are there. There cannot be any category in between 1 and 2 and 2 and 3, right? Similarly, female also. Now, see in salary, it's a continuous. Beginning salary, it is continuous. Job time, it is continuous. And therefore, I will have to, okay, anybody can tell me that this minority, is it categorical or a continuous? Please write down in your chat box. Is it categorical or continuous? It is having only 2 responses, yes and no. Is it categorical or continuous? Tell me. Please. Yeah, it's a category. Fine, good. Now this data is related to US 1994. Okay. And it is not our Indian data set. It is a default data set which is given in SPSS data, SPSS with SPSS software. Okay. So I can generate the histogram of this salary. For that purpose, what I'll do, I'll go and analyze descriptive statistics, descriptives, right? So here I will get the statistics related to this, but don't use this option. Use the option of graphs, legacy dialogues, and go in histogram. Transfer current salary here and say display normal curve. Click OK. And now you will get the data which is continuous. Right? Is it clear? Let's proceed further. What type of statistics can be generated here when my data is continuous? What type of statistics? So here I can generate mode. Here I can generate mode and median. Here I can generate mode, median, and mean. Please write it down on one page. That in case of nominal data, you can generate mode. In case of ordinal, mode and median. Here mode, median, and mean. In case of interval or ratio. From where I can generate this statistics, again I will go back here, analyze descriptive statistics. Now the first option, which is there, frequency, it has been kept reserved for nominal and ordinal data. Please write down on one page. The first option, analyze descriptive statistics, frequency, it has been kept reserved for nominal and ordinal data. And here, this has been kept reserved for ratio and interval, descriptive statistics, right? So let's go here and select current salary options, minimum, maximum, standard deviation, everything will be generated. Click OK, and you will get the answer. See, is it there? Minimum salary, the maximum salary, mean, and standard deviation. It's a univariate analysis where single variable is only involved. Only one variable is involved, no other variable. Okay, let's proceed further. That, say for example, now there is an involvement of two variables together. Now collectively, nominal, ordinal is no, and here interval and ratio collectively. These two are known as metric. It's a metric data because you know this is continuous, and this can only be measured by with the help of scale, and scale can measure meter, and therefore it is metric. This is non-metric. So any data which is continuous is metric, and therefore I can apply parametric test here. And here I can apply non-parametric test. Now if I combine and have a set of combination of non-parametric, non-metric, and metric, non-metric, and metric. So if I say here that here we are having urban and rural, and here we are having male and female, right? So what type of things I can do here? So I can plot the bar chart, which is stacked or unstacked bar chart. Is there any question? Okay. Stacked or unstacked bar chart can be plotted. Okay. How I can do this thing? Simply, I'll go and analyze descriptive statistics and cross tabs. Now this time I will take gender here and minority classification here, display clustered bar chart, cells, row, column, continue, click OK. You can see carefully that how many male, female. I can display the percentage also. I can go here and I can have a percentage. If I want to display percentage instead of count, I'll take this up, I will remove this, and I'll say apply, and now I will get the percentage. Is it clear? Both are categorical to categorical. Done? Okay. Now what to do in case of when both are metric and metric? For example, weight and blood pressure. We can have a scatter plot. So here I want to see the relationship between my current salary and the beginning salary. So I'll go in graphs, legacy dialogues, and scatter dot, simple scatter, define y-axis, current salary, and beginning. Okay. Both are in metric to metric. Now, can I introduce a categorical data here? Categorical variable here? Yeah, I can do that. I can again go here and I'll say set markers by gender. Okay. And now see, we will get a different graph for male and female. Okay. Let's proceed further. Simple scatter. Can I give the label cases by for identification? I can do that also. The cases will be labeled. No, it's not working. It's not working here. Come back here. Now what we can do here when one variable is in metric, blood pressure, another variable is in category, and you want to see that is there any difference or not. So here also we will have a bar chart only. The only difference is that here the bar chart which will be plotted, it will be based on the mean. It will be plotted on the base of mean. This is mean and this is actual frequency. This is actual frequency, right? So how we will go ahead about this graphs? I can use nice descriptive, just a minute, chart builder. Okay, just a minute. Bar chart. And here I can drop beginning salary or a current salary here, and I will drop gender here, right? And click OK, and you will get the result, right? See what it is displaying. Simple bar mean of current. This is mean salary, right? It is not a frequency on this y-axis. It is not a frequency. It is a mean. In all previous cases, it was a frequency. Count was there. Here the mean is there. Is it clear? Now, if you click here, it will not give you the percentage. You cannot write the percentage because it will not work. Percentage will not work only, right? Because you can have only the mean of it, right? Shall we proceed now? Okay. Now here at present, keep the things as it is. There is no chart which we can display here. What type of statistics can be deployed here? But before that, say for example, what is a procedure for converting our data from continuous to categorical? Sometimes we want to convert our data from continuous to categorical. I'll give you one option. I'll give you one example to this. The marks of the student are there. Can we convert it into percentage? Yes. Can we convert it into what rank he or she is holding in the class? So first rank. Can I convert this thing into pass and fail? So this is the procedure of converting the continuous data into category. Okay. Can I go reverse? Anybody? If categorical data is given, can I go back and tell what the marks are? Write in chat box. My question is very simple. No, you can't do that. So it means that you are all listening. Very nice. I'll give you another example to this is that you are having a LED TV. Full color. You can convert it into black and white if you want. But if you have purchased a black and white TV, you cannot convert it into LED TV. It means that suppose you are doing some analysis and you feel that the grouping was not done correctly. And if you are having access to the original data, you can do the regrouping and again you can come out with the new result. But if you have collected anything on grouping directly, you cannot go back and tell what the original marks are. Okay. So here there is one continuous data selling. I want to convert, or rather previous experiences of an employee. I want to convert this previous employee into newcomers, experience, very heavy experience, like that. So whenever I do such thing, it is always necessary that I should be having a minimum and maximum value of any data. So what I'll do is I'll go and analyze descriptive statistics and first descriptives, and I'll drop this here and I'll write down previous experience. So my minimum previous experience is 0 and maximum is 476. I want to do the binding. This is known as a binding. How we can do this binding? Let's see. File, new.
Dhaval sir, the screen is not visible.
Why?
2 minutes back it was there now, but now it's not visible.
Is it visible now?
Yes, sir.
Yeah. Now see. 0 to 476 experience is there, right? Now I can divide my data into 0 to 100, 100 to 200, 200 to 300, and 300 to 400, right? I can take this approach, or I can use 0 to 250, 250 to 500, whatever. It is up to the researcher or what type of statistics which you want to generate, I can do that. So 0 to 100 are trainees, those who have just joined, less experience, moderate experience, heavy experience, and rich experience. Right. I want to do this on my data set. Now, from where this option is available, you go here and transform, recode into different variable. A window will appear. Now, in this window, what you will do is previous experience, you will transfer it here, and I'll click on old and new values. I'll specify the range 0 to 100 is now known as 1 because it's a new thing which we are making. Trainees. Add 101 to 200 to 201 to 3, add 301 to 400, add 401 to 476 is the last number. So I'll say 5, add, continue. And now I'll have to give the new name to this variable because I'm converting the variable. And therefore, it is a normal practice that whatever operation which we do, we give prefix of that operation only. So previous experience is now recoded. Reco, previous experience. Reco, previous experience. Change. Right? Click OK. If you go in the data set, a total new variable has came into the existence. See? Now, I cannot have a histogram of this, but definitely I can have a histogram of this. So when I go and analyze descriptive statistics frequency, and instead of this, let me take both the variables, previous experience also, whose frequency I will plot, which is not possible. Enrico, previous experience, charts, bar chart, continue, click OK. Now, if you see this carefully, this is total failure, this one. Because I cannot plot the chart of the continuous variable, and this is completely mess. The variable which was not coded properly, the original one. This is coded 1, 2, 3, 4, 5. 0 to 100, 101 to 200, 201 to 300. This, how to get this output, I will also show that thing. But first of all, see. Now see the output is very clear. 1, 2, 3, 4, and 5. But I want to display the names here, that what is 1, what is 2, what is 3, 4, and 5. So I'll go here back in variable view, and here I will open the window, values, and I'll say 1 is, what was the name which we had given? Trainees. So 1 is trainees. 2 is low experience. 3 is moderate. 4th is heavy. 5 is rich. When I run the graph again, it will give me now a good result. See? Is it clear now? Are you able to see? Much organized format it is giving. Right. So this is converting your data from continuous to categorical. It may also happen that you want to create the new variable. That is, existing variable is, this variable is there. And you want to convert this salary, which is monthly, into annual salary. So how can I do this? Right. So I'll go in and transform compute variable. I'll say current salary, which is monthly, asterisk into 12. And this I'll say as annual salary. Click OK. Completely new variable will come into the existence, which is 27,000 multiplied by 12. Yeah, question is there? It's going good. Okay. Thank you. Thank you. Thank you. Fine. So this is converting my present salary into monthly salary into continuous salary. Is it clear? Now you want to give the promotion to a worker. Let me show you one case study. Okay, all of you read this case study so that you can understand what we are going to do. So research methodology and question is that this and feedback. Yeah, you will get the feedback. Just at least pay attention here right now, right? Now see, this is a problem which is there. This is a case study. Right. A company wants to give increment of 20% for employees who are at managerial level and having an education of more than 8 years and having previous experience of more than 60 months. Okay, so we don't want to give promotion to each and everybody. There are specific group of people whom we will pick up and we want to give the promotion to them only. Right. So how we will do that? So first of all, I will go in transform, compute variable, and there is if. See here, there is if condition. Is screen visible? Say yes or no. Please write down, is screen visible? Please write down. Yeah, fine. Is screen visible? Yeah, okay. Then reset. Because there is a previous condition which is running, reset. Now go in if, right? And I'll say that only those cases are to be selected. First of all, employment category should be 3. Then what is the next condition? Having education of more than 8 years. Okay, let's go there. And education level more than 8. And previous experience more than 60. Continue. And the condition has been specified. So all those who satisfy this condition will get an increment of 20%. So just write down here increment and current salary asterisk 1.2 times. So 120%, right? Increment. If they can satisfy this condition, it means that all of them will not be selected. Click OK. Go in the data view and you can see only those people who are satisfied, who got this, right? Now this list is completely randomized, but I want to make it in the sorting way. So where I'll go in data and I'll say sort. Data. Pragati ma'am, can you take the charge of this matter? Increment, ascending. Okay. And again, you will see this. The increment is like this from the last. It will give me the list of all those employees who got the increment in the ascending order. Right? Is it clear? Shall I proceed further? Any questions are there? Okay. Now, I don't want to work on entire data file. I want to work on selected cases. That I'll be computing the things only of male or female. I want to, you can say, hide the data, or I will say I don't want to print the data of those which don't satisfy this condition. So I'll go in and data and select cases. So I don't want to work on the entire data set. I'll say only those if, again the same window will appear, gender equal to male, continue, okay. Let me see, is it working? Yeah, see. Only, now there is a cross. Only those which satisfy, only those observations will be selected which satisfy this condition, male. Females are completely, you can say, crossed, in the sense that no data will be generated of female. So suppose in your organization, you want to generate a separate data of male and female, definitely you can do it. This is one method where most of the time you get annual data of the India, and now you want to generate the data state-wise by filtering the other states. So this is also possible where you blind the data. This is one method. Another method is that to run multiple analysis, instead of this, there is one more method. I'll go in data, select cases. Now this filter which was there, I'll say all cases and the filter is gone. Right. So I'll say data, select cases. No, data, split file. Organize output by groups, gender. Organize output by groups, gender. Okay. Now nothing will happen here. But when I generate the statistics of this, descriptive statistics, and when I generate statistics related to this, current salary, beginning salary, months since hired, previous experience, and when I click OK, it will generate the different statistics for female and male. Is it clear? Because we have splitted the file. Done? Are you all able to understand? If you are able to understand, just write down in chat box done. Okay. Shall I proceed? Right. Now, as this is on, again go back and make sure that the splitter is off now. Otherwise, each and everything, it will generate by split only. So analyze all cases, do not create groups. Click OK. Now there is one more method, analyze descriptive statistics, reports and OLAP cubes. Very nice thing which they have came out with. Current salary, beginning salary, months since hired, previous experience, no splitting required at present. And insert the gender here. Statistics which I want is mean, okay, standard deviation, this, all these things are fine, punch it. And click OK. You will not find any difference in the chart which is being generated or the graph table which is being generated. But just click here and click here and it will show something. Now, give me the chart of female. Give me the chart of male. Okay, and total. All these things will be generated. This is OLAP cubes. Done? Shall I proceed further? I can also generate my result in another format, that is analyze and tables and custom tables. Okay. A canvas will appear. Now, in what form I want the statistics, I can select. Normally, the gender was like this. So I will say I want gender here. Or let's say, for example, employment category here. And all the statistics which are related to it, I want in rows. Current salary, beginning salary, months since hired, okay. I can go in summary statistics and I can also select what I want. Row total, column total, mean, median, mode. I can select everything right from here. At present, to keep life simple, apply to selection, apply to all, close, okay. I get the statistics like this. Done. Same thing. Can I generate it in a different format? Yes. Again, I'll go in custom tables. Okay. And just see here, I'll say columns, transposition rows. Just change this and transpose. And things are not transpose. Let me go there. Small transfer is being done or not. Columns. Wait a minute. Default. Yeah. You have to change this column label in positions. Click OK. Now see. The statistics will be generated by this method. Okay, shall I proceed further? In data, I can also, most of the time we get too many duplicate cases. So for that purpose, I'll say identify the duplicate cases. I will have to give the criterion and it will tell me that these are the duplicate cases that I can do from here. Okay. Then there is something which is rank the cases. I'll have to give rank, the current salary, and the gender or minority, and click OK. Right? When I'll go in my output, you can see the ranks which have been given according to the gender, that who is holding the first rank in terms of salary. I can go here, data, and arrange in ascending or descending order. So I get like this, ascending and descending order, male and female. Right? So this option is over, this is over, analyze. Now in analyze, let's again go back to this part, this one. But what else we can do here when we are having such type of data? So here, Pragati ma'am, or the lunch break is at what time? What is your break time?
Hello.
Yeah.
Yes, sir. Sir, it's up to you. When you feel, you can give the break of 5-10 minutes.
Okay. Okay. And we have to go up to what time, ma'am?
Till 5 o'clock, sir.
Okay, 5 o'clock. Fine. So, okay. So let me draw this thing again here. And nominal, ordinal, interval, ratio, nominal, ordinal, interval, and ratio. Now, when the combination of this is there, we saw what type of chart can be there. But what type of statistics can be deployed? It is chi-square or cross tabulation. When there is a combination of interval ratio to interval ratio, we are using correlation and regression. And where is nominal interval to ratio, t-test is there or ANOVA is there. Right? So here, our null hypothesis is there is no association between X and Y. The word used is association in hypothesis. Here, we are writing there is no relationship between X and Y. And here, we are writing there is no impact of X on Y. here in this, we write there is no significant difference in blood pressure according to male and female, according to marks in section A and B, right? So first of all, we will have to pick up all the variables which are there, right? And on that basis, we will try to run the analysis. So first of all those settings which are there, which we have given, they are to be removed one by one. I will clear this. So no previous settings are there. Clear. Data. Any splitting is there? No splitting is there. Any transformation is running at the back of the mind? No, it's not running. Cancel. Right. So first of all, we will run cross steps, and we can run only between category to category. So gender is a category and minority is a category, right? Or gender and job category, job category and minority. Categorical variable are there. Can anybody frame a null hypothesis of this three? One null hypothesis of gender with job category, one null hypothesis of job category with minority, one null hypothesis of gender with minority. Quickly do it. All of you. Anybody who can frame the null hypothesis of this? Okay. Let's try. The null hypothesis is there is no significant association between gender and job category. Please write down on one page. There is no significant association between gender and job category. Or in other words, we can say that, that male and female are in all job equally in other job categories, right? So how to run this? Analyze descriptive statistics, cross steps. So in previous case, we only generated the clustered bar chart. Now you will generate some statistics also. So employment category, and here now you will generate statistics, that is chi-square. The rule of thumb is that if the p-value is less than if p-value is less than, p-value is the probability value, is less than 0.05, we reject. Null hypothesis. And if p-value is more than 0.05, we will not write we accept, we will write fail to reject. Or in a layman, don't write in your research paper, accept the null hypothesis. Done? Okay. Let's run this test and see what output we have got here. Click OK. Where is the chi-square? Okay, anybody can interpret this thing for me? This is a p-value. Anybody can interpret? What is the interpretation? P-value is less than 0.05. So what is the interpretation? Yeah, null hypothesis is rejected. It means that there is a significant association between the job category and male and female. It means that there is some pattern. Pattern is there. So just see here. In which category females are not there? In which category females are not there only? And the category is custodian, right? Now, can I say that the company's policy is biased towards female? Can I use such words in research? My question is, can I use such harsh words in research that there is no female in custodial? And can I write such thing that company policy is biased towards females? No, I cannot use such words. No, you cannot use such words because you are not aware what type of role the custodial is having. Okay, and probably the company must be looking from the safety point of view, and they must not be considering, or they must not be allowing females in this. So from the safety point of view, and therefore you will write that company's policy is biased towards females. It will be completely a wrong thing because here company may have a different view, right? So this is clear. Now let's go to the next compartment. Let's go to the next compartment. And the compartment is this one. This one. That if both of them are metric to metric, what I can run? If both of them are metric to metric, what I can run? That is blood pressure and weight. And what will be my null hypothesis? Quickly, just anybody can write in this compartment for correlation. What will be my null hypothesis? My null hypothesis will be there is no relationship between X and Y. The thumb rule remains same, and we will be carrying out the analysis between analyze, and then correlate and bivariate and current salary and beginning salary. Right? Click OK. And I'll get this result. So here, this is the p-value is less than 0.05. We reject null, and therefore it means that there is a relationship is there. Right? How much is a relationship? 0.88. We reject. Yes, we are rejecting null. 0.88. It means that the range of the Pearson correlation is between 0 to 1, and it means that it is having very high correlation. 0 to 1. Very highly correlated. Technically, we write as the p-value is less than 0.05, we reject null hypothesis. It means that x and y are strongly correlated. Okay, are strongly correlated. Now, what to do when we are having a combination of this? Combination of what? Salary and male female. One is categorical and another is continuous. So what we can do here? Which cell I am talking about? This one. And what will be my null hypothesis? There is no significant difference in salary of male and female according to the, there is no significant difference in salary of male and female according to the gender, right? And how will I go here? Analyze, compare means, independent sample t-test. And I'll click here, current salary, I'll take it here, and gender, I'll take it here. Define groups, male and female. Continue. Okay. And I got the result. Right? Now what you have to see here is this one. This one. The p-value is less than 0.05, and therefore we reject null again, and we say that the difference between male and female, the difference between male and female salary, mean of male and mean of female, the difference is very, very large. Because p-value is less than 0.05, we reject null. It means that the difference is significant, right? And therefore t-test statistics is significant. It means that males are getting more salary in comparison to female. Can I repeat this test for another variable? Yes, you can do it. Again, you go here, independent sample t-test. Now drop this thing here and include the minority classification here. Define this thing as 1 and this as 0. Continue. Okay. Right? This data set is always given in SPSS data frame. Always it is the oldest data set which is given with SPSS. You must also be having it in your system. Now just see here the p-value. They are less than 0.05. We again reject null. So depending upon minority, you get the salary, whatever it is, right? So we stop here and we take a break of 15 minutes. Over to you, Pragati ma'am.
Okay, sir, not an issue, sir. Participants, we are taking a break of the 15 minutes. Then we are again joining at 3:30.
I request that in the break, at least some of you install SPSS if it is possible.
Yes, sir.
Okay, thank you.
Thank you, sir. किती वाजता निघायचंय खरं नाही असं सांगा की 20 मिनिटात निघा
Okay, let us start again.
Yes, sir. Sir, there is another one question in the chat box.
How to do t-test? Okay. You go here in Analyze, Descriptive Statistics. Compare means independent sample t-test. Transfer the current salary here and minority here. Right. Now see, just see the p-value here. The p-value here is less than 0.05. It means that there is a significant difference between the male salary, those who are present in minority, those who are not present in minority. Right? Fine. Shall I proceed again? Is there any question related to this topic? No?
No, sir. Continue.
Now there are three types of t-test. One is one sample t-test, independent sample t-test, and paired sample t-test. At present, what we have seen is independent sample t-test. Let's see what to do in paired sample t-test. Normally, paired sample t-test is used when we are discussing something which is related to before and after. That before joining this seminar, your knowledge about data science, and after joining this before and after. So how we can do this thing here? We'll have to go and analyze, compare means, and paired sample t-test. So before joining the company, after joining the company, is there any significant difference in my salary or not? Click OK. Is anybody doing with me simultaneously? Say yes or no in chat box. So here, p-value is less than 0.05. We reject null. It means that there is a significant difference. There is a change in the salary, mean salary. The beginning salary mean is 17,000 and the current salary mean is 34,000. Now the CEO of this company has claimed that on an average we are giving 30,000 to our employee. So the null hypothesis is that the mean salary is 30,000. Now I want to test this claim of the CEO, that is the claim correct or not. Or say for example, his claim is that we are paying $40,000. So we want to say that is his claim correct or not. So on one side we are having claim of 40,000 and on the other side we are having a mean salary of all the employees. So we'll go here, analyze, compare means, one sample t-test, and I'll transfer current salary here. And the test value is the claim, 40,000. Enter. So there is a rejection of the null, and it means that there is a significant difference between the mean salary and the claim salary. The mean salary is 34,000, which is very, very less than what has been claimed by CEO of the company. Right. For example, if he would have claimed 34,000, what will be the scenario? Let's see. Again, I'll go here and I'll change this to 34,000. Click OK. And I get the p-value, which is more than 0.05, which means that the claim is correct. If he is claiming 34,000, the claim is correct. Right? Okay. So three types of t-test are there. Now, what to do if we are comparing more than two groups? Right? More than two groups. Here, the comparison was only between male and female. But if there is a comparison between clerical, custodial, and managerial, more than two levels are there. So in that scenario, we are not using t-test. We are using ANOVA. And for that purpose, from where to go? Analyze, compare means, and that is one-way ANOVA. Again, the current salary. And here, the comparison which we are doing is in terms of employment category. We carry out the post hoc study. That is post hoc. Why we are doing it? I'll explain it later on. Click on Tucky's test. Continue. I'll explain it. Don't worry. Before we run this also, let me show you something else. Before we run ANOVA, we'll come back here, but normally in most of the software, ANOVA is backed by one graph, and that graph is known as a box plot. Box plot, cluster, define, variable is current salary, and category axis is employment category. It's not generating, just a minute. Current salary. Employment category, and click OK. So I get the box plot. So you must not be aware about what is this box plot and how it is generated. Let's go there and try to understand that how we are generating the box plot. We have seen that in case of continuous data, we develop the histogram, and from histogram we develop the frequency polygon. Now, say for example, this is our frequency polygon, and we assume that our data is normally distributed. Right. Now, when I connect first quartile with third quartile, and these are plus or minus 3 sigma, and when I draw the second quartile, so plus this is minus 3 sigma, plus 3 sigma, first quartile, second quartile, and third quartile, and this is mean. And now if I just transpose it and make it like this, it is my box plot. If my box plot is normally distributed, means the shaded portions are equally distributed, it means that data is normally distributed. And equally, the whiskers should also be at the same length. And if they are at normally distributed, I can use all parametric tests, right? So we can see here, the skewness is there in the data. Moreover, see the mean here of the custodial, see the mean of this here, and see the mean here. So there is a difference in the salary in clerical, custodial, and managerial. Now, all this which are generated, 474, there are number of observations which are outlier, or rather observations which are beyond plus or minus 3 sigma, right? Beyond the mean of plus or minus 3 sigma. So we want to analyze this thing in terms of ANOVA, one-way ANOVA. I will go there. This time I will include the current salary here and employment category here, and post hoc, tucking, continue, okay. The null hypothesis is there is no significant difference in current salary according to the category, and the null is rejected. It means that the difference is there. The difference is. Pragati ma'am, can you take over the charge?
तो अभी कैसे पहुंचाएंगे?
Hello. Hello. Am I audible now? Hello.
Yes, sir. Yes, sir.
Okay. Thank you. If the p-value is less than 0.05, we reject null. It means that the difference is significant in all these three categories. Now, which two categories are having significant difference? For that purpose, we will have to see this one, Aki's test. Here, clerical is compared with custodial, clerical is compared with managerial, custodial with clerical, custodial with managerial, managerial with clerical, managerial with custodial. Now, clerical with managerial and manager with clerical, they are one and the same thing, only the sign will change, positive and negative. Otherwise, the things are, you will get the same result. So those pairs whose p-value has gone below 0.05, significant difference lies in their salary, mean salary. So clerical and managerial. Let's see in clerical and managerial, yes, the difference is large. Okay. Custodial and managerial, yes, the difference is large. Clerical and custodial don't have a large difference because p-value is more than 0.05, and therefore that also we can see it here. This is one way ANOVA. Is it clear? Is it clear? Shall I proceed further? Okay. Now this one way ANOVA has got one more design, and that design is that what is the probability? You must draw the design for you first, and then I'll talk about the probability. Then in one way ANOVA, we are only seeing the effect like this. The effect is seen like this only, right? So for example, clerical, custodial, and managerial. I'll give you one another sum. That is heavy water, moderate, and light water. Detergent A, detergent B, detergent C. Another example is section A, B, and C. Teacher A, teacher B, and teacher C. Right. And here the scores are there. So in case of two-way ANOVA, we are definitely capturing the effect like this. This is one thing. One, this effect is there. This effect is there. Straight. Is there any significant difference in the cleanliness according to the type of water, according to the section? One effect. Now there can be another effect also which we have to see, and that effect is like this, right? This way. That is there any significant difference in cleanliness according to the detergent? Or is there any significant difference in marks according to the teacher? This is also there. So two effects are there. One this side, two other this side. And sometimes it happens that a particular detergent combines with a particular type of the water, and it may give you a good result, like here. Or a particular teacher is comfortable in particular section and it gives you the good result. So such combinations are there or not, that we have to see. And that is known as interaction effects. So that is a two-way ANOVA. Main effects 2 and interaction effect 1. So how we can do this? So I'll open the data first and then we'll be working on it. Data set, that is no, not this one. Not this one. Yeah, see. We are having location of the store and type of the store. Right. What is the location of the store? Let's see. Location of the store is city central and suburban shopping center. And the type of the store is variety store, department store, or discount toy store. So 6 combinations will come into the existence, and on that basis the sales are there. Now, I want to say that is there first effect of location on sales 1, type on sales 2, and interaction effects are there or not. So for this purpose, you have to go in analyze, and this time we will have to go from here, right? Generalized linear model, univariate. My dependent variable is toy sales, location of stores, and type of the store. And click on post hoc, and again location and type, Turkey, continue, and click OK. First of all, let us see, is the effect of location there or not? You tell me, this is a p-value. Effect of location is there or not? Anybody who can tell me effect of location is there or not? P-value is more than 0.05. No, the effect is not there because p-value is more than 0.05. Similarly, here also the type effect is not there, but the interaction effect is present. That is, location and type is there. Now, which effect is more prominent, right? So variety store compared with department store, variety store compared with discount toy store. So wherever the p-value goes below 0.05, the effect is more, right? The effect is more. So clear, the effect is more. But here we can see that more or less all the effects are similar, right? So one is the main effect, location, then type, then location into type. Now let's come again to this compartment which is left out. That t-test is done, ANOVA is done, chi-square is done, cross-tabulation is done, correlation is done, regression is done, but left out. Regression, what we want to say is that is there any effect of other variables on my salary? I want to make a model and my present salary is affected by which variables in the model which I have collected. Okay, so anybody who can tell me which are the variables you think that are influencing my current salary, from here only you will have to pick up. These are the variables. You write down in the chat box. Anybody who can write down, my current salary is dependent on what? Job time. Okay, so you feel that job time is affecting. Okay, is there anything else? Job time means from how many years or from how many US experience is how many months he is with the education, right? So I want to build a model which says that my current salary is getting affected by how much education I have achieved, what was my beginning salary, what was my job time, and that is from how many months I am with the company and my previous experience. Yeah, working hours is the data which is not captured only. There is no working hour data which has been captured, right? So let me close this. No. So, so I'm making a linear model which will describe the thing like this, that y is equal to alpha plus beta x1 beta 1 plus beta 2 x2. Right? Now this is a constant. It means that in the absence of all this independent variable, still the value of alpha is there. Or in other words, say for example, if you don't take the blood pressure pills, your blood pressure is not going to become zero. Your stock market, if FIs don't invest, it is not going to become zero. So it starts with some constant, and therefore constant is always there in any equation, right? So I want that I want to predict my current salary on the basis of beginning salary and education. Now there is some null hypothesis. First null hypothesis is HO. I'll show you one figure which will be more, you will be able to correlate yourself with the figure. Just let's see this figure carefully. We are trying to understand regression analysis. And what are your observations? Please write down in the chat box. What are your observations? Just write down. The observation is no, that is not the observation, Pragati man. We want to see, we want to explain the dependent variable, right? With the help of these three people who are trying to pull the string. Just understand that there is a tug of war. This is a dependent variable, right? Now, I will ask you some questions which you will have to answer. Do you think that all these male are pulling the string with the same intensity? Say yes or no. Or their pulling strength is different, right? It means that the explanatory power of each independent variable is different. Is it clear? Another thing is, there is one person here who is not at all helping in pulling the string, right? He's just like, you can say, a person in the organization who is just trying to help you, but he is not helping at all, right? So there are some variables in a model which are insignificant, or rather they are not contributing anything in this exercise. So individually, are they able to contribute? That we have to test by the t-test. And collectively, is a model working or not? That is being tested by ANOVA. So whenever you run regression, spontaneously t-test and ANOVA will be generated on its own. Okay, it will generate the t-test and ANOVA on its own, right? So first is individual, are they contributing? Collectively, are they contributing or not? That is ANOVA. Now, how much pressure is being exerted? That is R square, the explanatory power of the model. More you can say it is always between 0 to 1. Coefficient of correlation is always between 0 to 1. More the correlation, more the coefficient of determination, better is the explanatory power of the model, right? So let's run the model and see that my current salary is dependent on what. So analyze descriptive statistics, regression, linear, and current salary here, beginning salary, independent, education level here, months since hired here, previous experience here, minority classification here. Then click OK, and you will get the result. First of all, you will have to see individual and ANOVA. Individual constant is always there. I explained. Beginning salary, P value, less than 0.05. Contributing, yes. Education level, contributing, yes. Months since hired, contributing, yes. Previous experience, yes. Minority classification, yes. Okay, is it okay? Yeah, I was waiting for that, Kishore Caldante. I was waiting for that. Deliberately, I had spoken a wrong. Sorry. Sorry. Pragati ma'am, who is it? Minority.
Someone's background.
Yeah. Minority is not contributing. You are right, Kishore. Because the p-value is more than 0.05 and therefore minority is not contributing. It is exactly like this person who is not contributing in the model, right? So we will have to remove this one. Second, let's see ANOVA. What's the p-value of ANOVA? Is it significant? Yes, it is also significant. So this is also a good sign. Then we see the R square, the explanatory power of the model. Is it good? So 81.1% is the explanatory power of the model, which is considered to be very, very good. Right, which is considered to be very, very good. 81.1%. Now let us go back again. And in this linear regression, we will remove minority classification and click OK. Now, is everything okay? Confirm. Is it okay? Everything is confirmed. P value less than 0.05. ANOVA significant. R square is okay. Shall we proceed?
Yes, sir.
Yeah. Okay. Now, sometimes we want to include the interaction effect in our regression model. That months since hired and previous experience. Okay. How to interpret that is left out. It is completely left out. But how to interpret this model? So this model is to be interpreted in. When we say that my current salary is equal to plus 1.768 times of beginning salary plus 669 education level plus 161 months since hired minus 17.30 previous experience. This is the equation which we have formed. Okay. Now see, what does it mean? It means that increase in beginning salary means if your salary increases by $1 beginning salary, your current salary will increase by 1.768 times. If your education level increases by 1 standard, your current salary will increase by 669 rupees. If your month since hired increases by 1 month, your current salary increases by 161. And if your previous experience increases by 1 year, then your current salary will decrease by 17 rupees. It will decrease. Now, this is something weird. Then how it can be possible? Fine. Now, you can have a justification of this also. You just see the packages which are given to the movie stars which are there. When they enter in the industry, their package goes on rising. And after some time, with the age, their package starts reducing. You see the cycle of IT company employees. Till the age of 40, their package goes on increasing and then it goes reduced. So it can happen that previous experience may be detrimental in your model. It can happen. Now I want to see that is there any interaction effects here? And for that purpose, whenever I want to include the interaction effects, say for example, I want to include the interaction effect of job time and previous experience together, because most of the time they go hand to hand. And therefore, to do that, I will standardize this variable and I'll go in analyze descriptive statistics descriptors. And I will transfer this here, 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 and here. And I'll say job time. Month since hired and previous experience. And there is a small tick which I'll do here, which will generate my standardized score. Click OK. Now, when I go in data view, the additional Z job and Z standardized have came into the existence. I want to see the interaction effects of this too. So transform, compute variable, and reset, transfer this, asterisk, transfer this, asterisk, and interaction. Okay. It's okay. And then again, I go in regression. This time, I insert the interaction effects here. Click OK. And see, is it significant? Anybody can say yes or no? Is interaction effect significant? Yes or no in the chat box? No. So interaction effects are not significant. Okay. Now I want to generate the different regression equation for male and for female. So again, I go in data, split the file, and I'll say organize the output accordingly. Click OK, go integration, linear regression, and click OK. So two separate regressions will come into the existence, one for male and another for female. See, female, what is the scenario? And male, what is the scenario? So these effects are known as mediators and moderators effect in your regression. It's known as a mediation and moderation analysis in SPSS. Now, all these statistics you can use only in one scenario, and that is the normality of the data. Okay, normality of the data. That is t-test, ANOVA, correlation, regression. That data is normal. Now, what is the whole concept of normality and why we are testing the normality? Let's understand. Normally, we test the normality in terms of continuous data. Now, why it is always a bell-shaped curve? Let's understand. What is the probability that there is a very tall student in your class? What is the probability? Very less. The probability is very less here. What is the probability that there is a very short student in your class? Very less. More and more students will be towards the center, right? Assume that there is a traffic, just stand on any crossroads and see the traffic congestion which is happening according to the timing. Another example. Yeah. Another example. Say for example, 12 p.m. And this is 6 a.m. in the morning. This is 6 p.m. in the evening. Now, with the time, the traffic congestion will increase at the crossroads. It will take the peak at some time, and again it starts reducing. So the normal distribution is followed by most of the phenomena. Okay. Now, why we are insisting on normal distribution? Because when we take our observations, samples from normal distribution, whatever conclusions which we draw for the sample will be applicable for the population. Because it is not possible for us to work on the entire population, and therefore we work on sample. It is exactly like, let's say for example, you are infected with malaria and your doctor is extracting 5 mm blood from your body. And the doctor assumes that this 5 mm blood which is extracted from your body is having all the characteristics of the blood which is there in your body. So whatever conclusions which I will draw for the sample will be applicable for the population. Right. Now, doctor is not going to test that is it a true representative of this person only, because he knows it, that I have extracted the blood from his body, and therefore it is of this person only. But in case of social science, when we are dealing with some population, and when we are extracting a sample from it, we have to do some test that is sample representing the population or not, truly representing the sample or not. Is it clear? Are you able to get what I'm trying to say? Are you able to get it? What I'm trying to say? Now, it may happen that there is a skewness in your data. It may happen that there is a skewness in your data. Now, what is this skewness? I always take a layman example so that you can understand these things. The statistics is really a heavy subject, but I take okay. Now just see. Your mother has made a soup for you. Now, does it matter that from which side you test the soup? Does it matter? Say yes or no in the chat box. Does it matter? No. Fine. Now you have added a pinch of salt in it because you found it less and therefore you added a pinch of salt in it here. And you did not stir it. You did not stir it. Now, does it matter that from which side you are testing it, the soup? Does it matter? Yes. Now, what will happen is just imagine that the particles of the salt get settled. What are the chances that the salt particles will come till here? Very less chances. You are not stirring only. You don't stir. And therefore, when I superimpose this, I will get something like this. This is skewed distribution. In skewed distribution, my conclusions from this side are completely different from this side. Say, for example, if I am doing a study on quality of life of people in Mumbai, and I collect the samples from all posh localities and from slum area, my view from both the sides are different. And therefore, we want to check that is there any skewness in the data or not, or in other words, is my data having normality or not, right? How can I do this? So there is a procedure. Before SPSS, we used to do this in skewness by using the skewness in kurtosis. Now that days are gone. Now we can directly check the normality in the data by analyze. First of all, let us see without any test that is salary having normality in the data or not. Graphs, legacy dialogues, and histogram and current salary. Is it having normality? See, male and female are bifurcated. I will have to close this. Okay. Is it normally distributed? Can everybody tell me? Do you feel is it normally distributed or there is a skewness in the current salary? Is it normally distributed or is there any skewness in the data? Yes, skewness is there. We can see from here directly that the skewness is there. So how to confirm it? So preliminary statistics which were there before SPSS. So we used to go in few descriptives, previous experience removed, this is removed, current salary here, options, skewness, check the skewness, continue, okay. And we see that 2.125 is a very, very skewed. It's a very heavy skewness is there. It should be actually zero. Skewness should be zero. Right? So it is a very heavily skewed. Now there are some formal testing methods to check that the presence of normality is there or not. And for that purpose, I go in analyze and in analyze descriptive statistics and cross, just a minute, explore. Now I'll transfer the current salary here. Statistics, outliers are to be calculated, plots, normality plots with test, histogram, continue, options, continue, bootstrap, continue. Any questions are there? What is the standard value of kurtosis in normal distribution? Hello. So here, current salary, we have to take it here. And it generates some statistics like Kolmogorov, Smirnov, Anderson, Darling. These are the things which are there, right? Skewness, I'll write it down here. That will be much better right here. Skewness standard value is 0 and kurtosis standard value is 3. Okay, let's go there. Click OK. Right. Now see the p-value. Normally we see the Shapiro-Wilcoxon test. The p-value, the null hypothesis is data is normally distributed. The null hypothesis is data is normally distributed. The alternative is data is not normally distributed. Here, the p-value is less than 0.05. We reject null. It means that data is not normally distributed. 1. Confirm. Histogram confirm. Now, this is a stem and leaf plot, right? How it is generated, I'll show this. I'll explain this, that how it's working. Say, for example, you are having data like 11, 12, 13, 21, 22, 14, 23, 31, 34. All of you be with me. First data, 1, 1. Second data, 1, 2, 1, 3, 2, 1. So new root is necessary. 2, 1, 2, 2, 1, 4, 2, 3, 3, 1, 3, 2. Clear? Is it clear to all? Say yes or no in the chat box. Clear? Okay. Now, if I remove this and if I take this data set, right, this one, this much, and I bring the data set here, I spin the data, if I draw the line on this, see this diagram. Is both of them same? See, Is both of them same? See this. So it is another way of representing the data, nothing else, right? Nothing else. So stem and leaf is there. Now, if your data is normally distributed, most of the points, these points in normal QQ plot will be lying on this straight line, which are not, right? In normal QQ plot, most of the points will be lying on the straight line, which is not there, right? Another thing is, in detrended normal QQ plot, most of the points will be nearer to 0, and they should not be far away from this 0 axis. But here we can see that they are far away from 0, and therefore normality is not there. And the last, you can see the box plot and the outliers. Now, the observation number 474 is a very, very heavy outlier. Now, what is this outlier? Let us understand. First, we will talk about observation number 474. We go in the original data set, and when we talk about the salary, see the salary which is running 15,000, 16, 15, 16, 16, and now I will directly go to observation number 474. See this, 29,400. And what is the salary here? I am making some mistake. Oh, wait a minute. Yeah, on an average, we are getting 57,000, 40,000 like that. But when we compute the mean of this, so 29,000 is almost out of the range. Similarly, 471, 473, right? And therefore, these are outliers which are beyond the limits of plus or minus 3 sigma. Now, what to do with these outliers? Normally, people say that if the outliers are less than 5%, you should delete those observations which are having such weird term. I'll explain the outlier in another different format or a different in a different way. We used to play a game in our childhood. Identify the odd man out. You all know it. It is chair, right? Similarly, say for example, you had collected some data and you had taken the monthly income of all the respondents. This is in dollars. So $2,000, first person understood we are talking about monthly income. $3,000, $2,500. Now one person misunderstood and he wrote the annual income, $3 lakh. Now what will happen? As this is a very high amount, the overall mean will go high. And what will happen is it will start dragging. It will start dragging the curve towards its side. It is just like a pinch of salt which you have added and you have forgot to stir it. And as the mean will shift, the skewness will enter into the data. And therefore, they are all outliers. If outliers are less than 5%, delete it. But if they are more than that, what to do? So one thing is that increase the sample size, one remedy is. Second is remove the outlier. And third is transform the data. What is transforming the data? I give the law of transformation to this data. The salary which is here, right? I'll transform it and compress it. And how to do that? I'll go in transform compute variable and I'll reset it. And I'll say I want to use the log transformation. ln current salary, log salary, and click OK. New data will come into the existence. See here, log salary. Now let us check that the new salary which is there, log salary, is it normal? Analyze, explore, log salary. Okay. Can anybody tell me, is it normal now? Is it normal now? No, still it's not normal because p-value is less than 0.05. But there are some corrections which have happened. You can see the distribution is getting a little bit normal. Anyway, the graph is getting okay, fine. This is okay. You can see the shift in the mean which has occurred. So, but still, the normality is absent. Now what? But isn't it showing kurtosis? Yeah, it's showing kurtosis. Definitely, it's showing kurtosis. Let us compute the figure of kurtosis also. It must have got corrected, but not up to that mark. The corrections will be there. Previously, it was 2. See the correction which has occurred. Almost it has reached to 1. Right? Now, what to do when you don't get the normality in the data? What to do? Can I use t-test, ANOVA, all that test? Can I use it here? Is it possible for me to use it? No, I cannot use it. And therefore, when you face such problem, when you don't achieve the normality, you go for non-parametric test. Right? Non-parametric test. And how do you do this? Analyze, non-parametric test, all the tests which were there in the parametric, all same thing, you can use it here also, right? So go in legacy dialogues and once 2 independent sample, current salary here, presence in minority 1 and 0, continue. Okay. So what is the difference between parametric and non-parametric is that the parametric test runs on mean. Non-parametric test runs on median. Parametric tests are most affected by outliers. Non-parametric tests are not affected by outliers. Parametric tests are more robust. Non-parametric are not robust. Parametric tests are rigidly framed. Non-parametric tests are loosely framed. Parametric tests are more reliable. Non-parametric tests are not so reliable. Parametric test requires the distribution, normal distribution. Non-parametric test can work on any distribution, right? Click OK. And this is your p-value. Anybody can tell me what is the null hypothesis, what we conclude, and what are our inferences? Anybody? What to repeat? Aruna ma'am, what to repeat? What to repeat?
Sir, question.
Yeah, the question is, what will be the null hypothesis? What is the interpretation? Now I explain you the data, how we are interpreting. What will be the null hypothesis? The null hypothesis will be, there is no significant difference in the salary, log salary, according, comparison is of median, according to the not mean rank. Kishore Kallante, not a mean rank, because mean rank is gone now. We are working here on median, right? Mr. Kishore, it's a median which we are working, right? Here the p-value is less than 0.05. We reject null. It means that the difference is large. The difference is very, very large, right? And therefore mean ranks are not same. Now you will ask me one question, that sir, if we are working on median, then why mean rank is generated? Why mean rank is generated? Right. So this mean rank is not of the actual salary. It is a mean rank is of the rank which has been given. Right. It is not of the actual data mean. It is of the rank which has been given, because the non-parametric works on ordinal data. Now what to do if we are having, Pragati ma'am, can you please take over the charge? Hello. Okay, now what to do if we are having more than two Pragati ma'am, can you take, hello. Okay, now what to do when we are having more than two groups, just like ANOVA? No need to worry. Analyze, non-parametric test, legacy dialogues, K independent sample, current salary, employment category, define range 1, 2, 3. Now here it will run Kruskal-Wallis test and click OK. Right? Anybody can interpret this result for me? P-value less than 0.05.
Direct highway ne jana hai.
Anybody can interpret this result for me? Yeah, we reject HO. It means that there is a significant difference in clerical, custodial, and manager. Right? Paired t-test. How to do it? Non-parametric. So I'll go here to related samples, beginning salary, current salary. Click OK, and you will get the results. Okay, now what to do when one more advantage also is there in non-parametric. See, very useful feature is there. It's really a good feature which they have introduced. I'll go in independent sample and I'll say compare medians across the group, run. Okay, I'll say current salary is here and my gender is here. Okay, see what it will do. I'll just press run and see the null hypothesis is also framed, the test is also done, and it also gave me the result also. Right, it is also giving me the result also, direct result it is giving me. See, with framing of null hypothesis. I again repeat this thing for you. Analyze non-parametric test. This time I'll say related samples. Run. Two fields I'll take, beginning salary and current salary. Run and see. Is it okay? Getting it? Hello? Are you able to understand? Hello? Fine. Now there are some graphs in which they have came up with the concept of the chart builder. Very useful concept. If you don't, yeah, is there any question? You will have to reset it. Now, say for example, if I select this clustered bar chart, it will immediately ask me that what are your x-axis and what are your so here I'll say gender, and I'm using as employment category here, right? Employment category, I'll take it here, and gender, I'll take it here, right? And I can use any filter is to be taken. So I'll say the filter is minority. On the minority, right? And that's the way I can go here. One more thing which I can do is beginning salary. Clustering should be done according to the gender. Click OK. See, filtered by male and female. Filtering is on. All these things you can do, right? This is basically using the dashboard feature. Now, say for example, if I want to make a pie chart, so I will just have to say count, okay, and it has given me the pie, male, female. Just drag it and drop it, nothing else. You don't have to do anything, right? You don't have to do anything. Now, some new things which they have came up with, the case summaries. These were not previously there. Case summaries directly. That you talk about the current salary and what are the case summaries related to the grouping variable. Click OK. Every feature related to this, they will generate male, female. The graph will be, sorry, the summary, it will give the summary that how the data is there. Tables, compare means, mixed models, neural network, everything has been done. Anything else which is left out? Format, insert, transform. Fine. This is the thing. Over to you, Pragati ma'am. Thank you. Any questions are there, you can ask. Hello. Pragati
Yes,
ma'am, over.
yes, yes, sir. Participants, any questions?
Just a minute. Can you give me 2 minutes, ma'am, Pragati ma'am?
Yes, 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 sure, sir.
Now, talking about me, I am into the teachers training program, and I am dropping my contact details here, right, in the chat box also. You can have it. Now we are into the training of somewhere around 40 softwares in which we teach SPSS, StatGraph, Jamovi, Minitab, MATLAB, Gretchen, EViews, MS, Smart PLS, Adenco, DOE, Atlas.ti, NVivo, R, RStudio, R Commander, machine learning using R, RRetl, RCaret, Weka, RapidMiner, Tora, Gephi, Python with Jupyter Notebook, machine learning on Python with Static Package, Stata, W, Power BI, Excel, Google Data Studio, and IBM Watson Predictive Analysis. Some of my books which are available on Amazon are, you just write down data analysis using not my name also, just write down this thing. Data analysis is using R book, and go here and images. Yeah, this is the book. This one. This is the first book which is being generated. Right now, it is having 3 additions to it. So if you are purchasing it, make sure that 2 additions which are very costly, don't purchase that one. I'll share the thing. Purchase the edition which is of 734 rupees, low price edition. The color edition is of 3,540. Right? Both are same, ditto. They are, only difference is black and white and color edition. There is another book which is also there, is machine learning using RRetl, available online. This one, right? You can use this book also for your study. Now, all those who want to get the notification of my upcoming programs, that the training on the softwares, you simply just send me hello on this number, right? On this number, I'll send you the WhatsApp link by which you can join my vast BM network, which is spread across entire globe, and 2,500 faculties from all over the world have joined it. And what are the advantages? The advantage is that you can post the programs. Your program brochures also can be posted in that. You can ask queries related to research. If you want to conduct any training program, you can post the programs in that channel. I'll forward it into all my other groups. There is no entry fee. There is no exit fee. You can join anytime. You can leave anytime. 3 things are not allowed: politics, religion, pornography is not allowed. So thank you. Over to you, Kavita.
Thank you so much, sir. Any participant, please? Any questions?
Any questions are there? Any questions?
Yes, definitely. It was totally practical oriented session. Lot of things the first time we done.
That's the reason I insisted that if the hands-on training was there, no, they would have done it, because all of them are having a computer and they could have done it very well. You can take my number, Rashmi ma'am. The number is there inside, right? Okay, so we'll end the session here, ma'am.
Just a minute. Now I request Nashra madam, please give a formal vote of thanks to sir.
Yes, ma'am. Okay. A very good afternoon, everyone. Now I would take the opportunity to end the day 4 session of this 5-day faculty development program with a formal vote of thanks on behalf of IT and CS department. I would like to thank our day 4 speaker, Dr. Dhaval Mehta sir, for giving us a detailed hands-on training on the SPSS tool. Today's webinar was completely practical oriented, which made us understand how complex statistical data analysis work. Again, I would like to thank Sir for taking out time from his busy schedule and sharing the knowledge with us. I would also like to thank our principal, Dr. Hemlata Bagla ma'am, for permitting us to organize this webinar. I would also like to thank my colleagues for organizing this webinar and inviting Dr. Dhaval Mehta sir to conduct it. Last but not least, I would like to thank all the participants present here for paying your sincere attention to this session. Thank you. Thank you, everyone.
Thank you. Thank you.
Thank you so much, Nashra ma'am. Thank you so much.
Thank you, madam. Thank you, madam.
All the participants, please note, tomorrow holiday, we are again meeting on a Saturday at the same time, 2 p.m. Thank you, all the participants.
Thank you, madam. Thank you.